Hey guys, welcome to another video by me, JP from Plumpot. If you're new to the channel, in Plumpot channel we make PCB tutorials using KiCad and Altium, and also when we create our own PCB designs and our own hobby projects, we give you step-by-step instruction how you can build it and how you can program it at home. But in this video we're going to look at panelization of a PCB. This comes from a viewer that asked us to look into this and explain a bit more how it works. So basically, panelization of a PCB is where you have one PCB and you place it in an array, let's say 4x4, on one panel by the PCB manufacturer like JLCPCB and PCB. It kind of looks like this on the top right. So you've got one design and you duplicate it throughout the panel. This makes manufacturing easier because manufacturers don't actually just manufacture one PCB, they do what we call a panel. When you order from JLPCB or PCBWay and you've not done this, they do it for you without you even knowing. So we're going to chat more about that, about V-scores, about mouse parts, and how to do this in KiCad. Two different ways, one using a plugin of course, and another one doing it yourself. We're also going to look at how to do different designs on one panel. So I'll show you guys on JLPCB, you can actually have more than one design on one panel. That saves cost, because in PCB design you pay for the panel size of the surface area used, not what's actually on the PCB. So let's get started. So why would you create your own panel in KiCad or Altium? Well, to be honest, if you're a hobbyist and you're just doing PCBs for fun, JLPCB and PCBWay will panelize your PCB for you, no issues. You can just make the single PCB, say how much quantity you want, and they'll do the rest without you even knowing. So why even bother learning about panelization if you really don't need it? Well, there's different reasons. The first reason is if you want to have different designs on it. So you've done many different designs and you want to save cost. Instead of making different orders, you order one panel with 5 different designs on it. This is the best and cheapest way to do things like that. Another reason might be is you have more control of where the breaks are of your PCB. So like I said, a panel looks like this, and you have different methods like a V-score or a mouse part. So when you let JLPCB or PCBWay do it for yourself, then they will decide where they place it, and you might get your PCB back with cuts and breaks where you don't want it specifically for a housing, should I say. Another reason might be if you're working with high voltages, there's rules that you can't have tracks close to edges. There has to be a certain distance. The same with ESD protection. You don't want tracks running across your board. You want a certain distance from the board edge. So if you use V-scores like this and they cut it, you actually lose some distance. Then you're not compliant to the rules and regulations of a certain voltage, because they cut it at 45-degree angles and leave you a little piece. You do lose a bit of, I think, 0.5 millimeters of edge. So that's also important to take. So that's the main reasons to do it. And if you just want to learn how to do it and play around with it, then you can also do it. But again, if you're just hobbying and learning and playing, the manufacturer can do it for you. Don't worry too much about it, but it's just interesting to see how they do it and why they do it and what you have to think about. Now that we kind of understand about PCB panelization, let's look at a practical example. So I'm first going to look at a way to panelize it using V-scores, and then look at panelizing it manually using mouse parts. And then last but not least, I'll do it using a plugin called KiKit, called KiKit, and then it'll be automatically done for you. Saves you a lot of time and a lot of effort. So let's get started. So the V-score is actually quite the easier way of doing things, but things you have to take note of is with V-scores can only go up to down or left to right, so it can just go in straight lines, and it has to go full from the top to the bottom. You can't just do sections. So that's important to note. So if, for example, you have a circle, you cannot do a V-score, because a V-score has to go straight. That means your circle will have a straight edge somewhere. So for a square PCB, it might be very good to use. Also, you have to note is a panel gets populated with components, and then afterwards it gets broken into pieces. So with V-score, you cannot have components hanging over your PCB, because when they depanelize it, they use a small machine almost like a saw to just run through and cut those boards in half through the V-score. So overhanging edges like this is not really allowed to have a V-score. I'll use it for example now, but in real life they won't do it. I actually got this board made, and I'll show you guys actually on this PCB where you see the mouse parts that they use. Like I said, the manufacturer will panelize it themselves. But let's look how we would panelize this board using V-scores. First thing you do is actually quite easy. Just highlight everything, right click, special tools, create array. So for example, I want 4x4. But what we have to be careful for is what's the dimensions of my board. Well, let's measure it. So from there to there is 88. So when I double click on it, I can see the dimensions, and it's about 88.9 by 101.6. Don't ask me why I did that. I think it might have moved around while I was making it, but it is what it is. So we take these values and keep that in mind. So 88.9, I'm just going to take a screenshot to save it. Now what I do is I highlight everything and I just say right click, special tools, create array. So I'm going to make a board 5x5, so 5 vertically and 5 horizontally, and my horizontal spacing is 88.9 because that's the width of my PCB, and vertical spacing is 101.6 because that's my height. I'm not going to have an offset, so they're going to be against each other, and let's say okay, and there we go. My PC is struggling with the graphics. So now you can see we've got 5x5. Let's make it 3D and see how it looks. So there we go. We made a panel sort of about 5x5. If you zoom in, you'll see it's kind of against each other. And the reason why you can't have overhanging components now is because you'll see my USBs colliding with components. So it's very important. With V-score, you are not allowed to have components overhanging. It's just a good example. My DC jack as well. So how do I indicate to the manufacturing that I want a V-score at these sections? Well, in KiCad you can't really cut out a small groove to make a thin piece in the middle. So what we normally do is we use a fabrication layer, let's say front fab, and all you have to do is just make a text saying V-score. The manufacturer will know. So if you go like this, V-score, and I paste it here, rotate it, the manufacturer will know that this line should be a V-score. So you can actually use ways for yourself to indicate, maybe make a different like dotted line here throughout, but we telling the manufacturer, please, this line here, make it a cut. KiCad gives you different layers to let you, helps you to let the manufacturer know what exactly you want, like that for example. So now they know that this is a V-score, so we got to do it here, 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 so horizontally and vertically and horizontally. So we got to do it where all we want to break it. So if you can imagine you've got this panel in front of you, the panel with all the boards, and how are you going to break it? You can break it like this, take it through the machine to cut it. So think about it practically, what will happen. So now that we made the panel for V-scores, there's something we are missing. So every single panel that you make will need edges that has no components on that your oven and pick and place machine will support. So if you look at this picture, this is kind of what happens with your PCB going through a process of pick and place and soldering. It starts off with a stencil printer where it just puts your stencil on, so it puts the solder paste on with like a squeegee type of thing. But what you can see is like a conveyor belt, and on the edges you want your PCB supported. So it has like rails on the edges, and that's where the PCB goes on. So you want to make sure there's no components on those edges. So it's always a good practice to add 5mm edges on your PCB for support. So with the panel we just made, if you draw squares or rectangles and make V-scores there with no components, it'll be very good to take it through this process. So you can see it's a normal conveyor belt system where everything happens and everything's efficient. So that's V-score. That's probably the easiest way to do panels. But like I said, if you've got circular shapes or if you've got components overhanging on the edges, you cannot use V-scores. You have to use a thing called mouse bites. So I'm not going to go too much detail with that. I'm going to put a video below because there's a lot of YouTubers who went in detail how to do it. I'll put a link below on the library used. So I just want to show you how a mouse bite actually looks. So if you push O to add a component and you type in mouse bite, you can see there you get different slots, and the library you can install is down the link below. So normally default you use the 2mm slot. So that just means that I've got a like a CNC machine that the production used, and they drill the sides. So what actually happens is, rotate this, they will drill a 2mm slot all the way around. You're gonna have to redraw this as your border outline, especially where the yellow is, but watch the video below, it's good detail. And then this is your mouse bites, so these little dots. So you'll see, let me just put it further on, Alt 3 for 3D, and somewhere here I should see, there we go. So it makes little dots. So this will be at the edges and it'll be easier to break off. I'm going to put a picture, yeah, somewhere, I'm looking there. I'm going to put a picture here, so you'll see how a panel looks that has mouse bites. But if you want to do this manually, watch this video below. There's a guy that really did a great tutorial on how to do it, how to draw it. It is time consuming. That's why I want to show you guys now how to use KiKit. So KiKit is a plugin that you can even manually or automatically install on KiCad version 6. I'll show you guys how. But this makes panelization much easier for you. So this will automatically do the different arrays, so three in the row, 3 in the column. It will do automatic spacing, automatic V-score, automatic mouse bites. So I'm going to show you guys how to install it and how to start using it and make your own panels. So the first thing you have to do is open KiCad version 6, and at the home page, your main page, you'll see Plugin Content Manager. Click on that and then you'll see some libraries and plugins open. So for the library, we're going to install KiKit, automation for KiCad. Install, and you have to push apply changes to install it. So click install, it waits for you and you say apply changes. We'll start installing. What I also like to install is just, okay, it's done. What I also like to install is the plugin or library, should I say. So this is like extra footprints and stuff you can use to make your production easier for the others. So just install that as well. Apply changes. Now if I open my PCB, I should see something here. So if I go to tools, external plugins, and I say refresh plugins, I should see something there. If you don't, I've got something for you to do. And you see I've got KiCad Panelized PCB. This did not work the first time for me. What you have to do then is go to your thing and say command KiCad command prompt. So you have to go to this and something like this will pop up. Now you have to type in pip install KiKit and push enter, and we'll start installing stuff. I'm going to put the link below explaining this as well. I've already had it installed, so you can see it's already installed. You will see a bunch of stuff installed, and then you can start using it. Then if you go tools, external, refresh, it should pop up. Now that we've got the plugin, how do we use it? So now that we installed the plugin, I'll show you guys how to activate it and use it. So normally all our plugins are here at tools, external plugins, and then you'll see the plugins here. If you don't see it, push refresh plugins and it should pop up. If it doesn't pop up, remember you have to install it using the KiCad command prompt. Just go back in this video and you should see it. So there you can see KiCad Panelized PCB, KiKit, sorry, and then on the top right here you can see it as well. So all you have to do is click on it and then a window should pop up. There we go. So it's quite strange that it doesn't take the initial PCB on my screen, but you have to select the PCB. So you select the PCB, I will take this, and now you can start setting up your panelization. So I'm going to have a grid. I'm not going to alternate it, so I'm not going to rotate it during my creating of the array. There's rotation. I'm just going to make a simple 2x2. You guys can play around with it. I'll put a link below for this plugin's help files, so there's a lot more you can do, but I just had enough time to make an hour-long video for everything you guys can do. So we're going to make rows 2x2. We're going to space it 2 millimeters by 2 millimeters. The reason for that is many manufacturers' default drill size is 2 millimeters. So that means when they drill the borders, the space is 2 millimeters because the drill bit is 2 millimeters. So it's just good practice to keep it 2 millimeters. Don't worry about the source now. Tabs, we make it fixed. Cuts, this is where you choose between V cuts and mouse parts. So V cuts is what we did previously. We just have it next to each other. You have it cut left, up or down, or left to right. And then mouse parts is what I want to do now. So mouse parts, the drill is those small holes it's going to drill. The spacing is how far it is. I like to make it 1 millimeters apart. And then offset is how far do you want it inside the board. So you can play around with this. I found that 0.2 works quite well. I'll show you a picture after it generates what I mean by this. And that's our cut. Framing. So this is what I meant about when you have components on the outside of the PCB. As you can see, I've got components on the outside. I can't put this in my pick and place file that runs like this because I've got stuff that's clamping here. So it clamps here to take it through the reflow oven. So I add an extra frame, a tab around the borders of 5 millimeters to make sure that my pick and place or my reflow oven can either support it or clamp it. So I say rail standard, and like I said, I make this normally 5 millimeters. You'll see when it generates, I'll go through it. Tooling, don't worry too much about that. Fiducial, I normally say 3 fiducials, and offset, you can make it, let's say 3 by 3, or let's make 2 by 2. I'll show you that. So fiducials, what your pick and place machine uses to see where your origin on the board is. So it needs a reference point. So the camera will go to the fiducial and knows that's my reference point, and all this components on the board is referenced to that point. It's just easier for the pick and place file machine to know where to put the components. I'm not going to do text. And then post. So post means after. I'm going to say a mil radius of 1 millimeters. So this is for this plugin. If you don't do this, it will just make a square where the space is for the mouse parts. To make it a bit rounded, you'll see I make it 1 millimeters, actually the radius, so it's 2 millimeters diameter. So you'll see now it will be a nice realistic drill going through it. Copper fill is, do I make my tabs also full of copper, so this can increase the strength of it. It's your choice to do it. And then all I do now is I say panelize. What you see is quite cool, is it shows you kind of what you decided to do over here. So you can just double check this. I made my layout 2 by 2. Tabs are fixed. Mouse parts spacing is 1 millimeters, so the holes are 1 millimeter apart from each other. Frame, because I need a frame for my pick and place machine, my reflow oven, and my stencil, so the whole conveyor belt that we spoke about. And then my fiducials as my reference points. Post milliradius is, you'll see in the middle here, it's the drill bit, so it's radius, double that, 2 millimeters diameter will give my spacing. And now we close this and we have a look. So there we can see it panelized. So there's my fiducials, it was 2 millimeters down, 2 millimeters right. It's on my support structure. So through the reflow oven, it will be supported on this. You guys can add more mouse parts if you feel that this is not strong enough. And then there you'll see mouse parts, it's 0.2 inwards. So you can actually make it 0. So if it's 0, then we'll just stay on this line, which might be easier to break off. But there you can see the 1 millimeter drill bit. So if you don't do the 1 millimeter, this will just be straight. And so this is 2 millimeter spacing, which I said, and you see it's quite clever because it only has a break off point there and not there. So because this is a tab, right in the middle, it's got break off there and there. So you get special mouse part tools you can use, or maybe you can just break it. You'll see. I'll do a zoom in because this is actually the board, and you'll see but PCBWay actually penalized this for me. I didn't do it like this, and you should see some places that you actually have some rough edges of mouse parts. So let's see this in 3D and see how it looks. And here is your penalization in 3D. You can see the mouse parts. If we zoom in here, it makes little holes here. So you can play around with offset, see what works best for you. And then you see the 2mm space here and the rail at the side where it will go through the reflow oven. There you see the fiducials. We say 3, so it's 2 on top and 1 at the bottom left here. You guys can increase the number of mouse parts you want here in the middle of the side. This is done by the tabs and your V count and horizontal count. So how many mouse parts do you want? So we said 1 1. So we got 1 1. So yeah, you can make it 3x3, 4x4. Just look at the maximum dimension that your PCB manufacturer can have in its pick and place machine or its whole assembly. So there is a maximum size. But also remember, if you make it too big with the heat of the reflow oven, it can actually warp a bit. So you don't want that. So try to find the ideal size. Don't have to be too big, but the bigger it is, the bigger the surface is, and the more it can warp, and it actually will start bending in the reflow oven. So that's it, guys. I showed you guys now how to create the panels manually, how to do it with a software or plugin called KiKit. Very nice. I hope it was useful. There's much more you can do with panelization, but unfortunately the video will be 2 hours long then. Play around with the KiKit functions. Let me know if there's questions. Join our Discord, and then we can see if we can help you if you want to change up a bit. As I said before, there's no reasons for you to create your own panel if you are just doing stuff at home for hobby, things like that. It does take time, but PCBWay, JLCPCB manufacturing houses can panelize it for yourself, and they're pretty good at it. But it's nice to know how to do it yourself. Have a great day. Until next video. Bye.